Hello, my name is Devabalan Rajendran. My metric ID is 10DDT22F2022.
Sarivran Devadas. My metric number is 10DDT22F2001.
My name is Navindran Murali and my metric card number is 10DDT22F2002. Today I'm going to give the answer for question number 1. Okay. Question number 1 is understanding one concept. Okay. Purpose of one. Okay. A wide area network, it means one is essential for connecting multiple branches of a company across different religions, providing a unfit infrastructure for communication and data sharing. For this company's expansion, one enables seamless communication between branches, facilitates access to centralized resources such as database and applications, and supports collaboration across geographically dispersed teams. So we are going to see the one operations now. One operates across the OSI model, particularly focusing on the lower layer. Okay, so there is three layer over here. First layer is a physical layer. This involves the physical connection, including cables, satellites, or fiber optics. And second layer is data link layer. Here, data link protocols such as frame relay, Ethernet 1 and PP provide data transfer across the one. And the third layer is protocol like MPLs, LS or IP are used for data routing and packet forwarding across the network. And these are the OSI models. We have 7 OSI models over here, and the first one is physical, second one is data link, third is network, fourth transport, fifth session, sixth presentation, and seventh application. Okay, so we have two one services over here, and then the first for physical is describes the electrical, mechanical, and operational components to transmit bits, and the second one for data link is describe how data will be encapsulated into a frame. And for common one terminology, we have latency, jitter, and bandwidth. Latency is to delay in data transmission, jitter and variation in packet arrival times, bandwidth, maximum data transfer rate of network. We are going to see the comparison of one connectivity option. Okay. So first we are going to compare tradition 1. Okay. So we compare with circuit switch versus packet switch. Circuit switch provides a dedicated physical path between endpoint, ideal for consistent real-time data but less scalable and costly. When it comes to packet switch, it shares the path for multiple data packets and more efficient, scalable but introduce variable latency. Second, modern one. Okay, so modern one, we compare MPLS with Ethernet 1. Okay. MPLS as multi-protocol label switching provides efficient routing, offering high performance with QoS, means quality of service for application like VoIP and video streaming. When it comes to Ethernet 1, there's cost effective and scalable. Ethernet 1 offers high bandwidth and is ideal for organization with high data transfer need. Third, we compare with internet-based DSL versus VPN. DSL is digital subscriber line is affordable but offers limited bandwidth suitable for smaller branches. VPN over Internet. Virtual Private Network provides secure communication over the Internet, making it ideal for remote branches or employees working from home.
Okay, today I will present about network troubleshooting for one connectivity. troubleshooting process. A structured approach to troubleshooting involves a 7-step process. Step 1. Identify the problem. Gather symptoms, error message, and affected area. Step 2. Establish a theory and probable causes. Hypothesize potential causes based on a collected data. Step 3. Test the theory. Check if the cause alignment with the problem. If not, move to other theories. Establish a plan of action. Once the cause is confirmed, create the solution. Step 5. Implement the solution. Apply the fix while monitoring for additional issues. Step 6. Verify the functions. Ensure that the issue is resolved and everything is function. Step 7. Document finding and solution. Record the problem, solution, and any relevant details. Okay. After that, network troubleshooting tools. First tools, software tools, ping and track router, basic basic network tools to identify and reachable and route of data packets. Wireshark, used for deep packet analysis to monitor network traffic and identify issues. After that, hardware tools, cable tester, used to verify the integrity and physical connection. Network analyzer, device that analyze traffic, latency, and bandwidth, providing insight on one performance. Okay. Symptoms and cause of one connectivity. Symptoms: high latency. Cause: network conjunction insufficient routing. Solution: optimize routing tables, upgrading bandwidth, and implants QoS. Symptoms of frequent disconnection. Cause: weak signal and hardware issues. Solution: verify physical connection, replace faulty cables, and adjust router configuration. Symptoms: slow data transfer speed. Causes: bandwidth limitation, executes traffic. Solution: upgrade bandwidth or implement traffic shaping or prioritize important data. Thank you.
I'm going to present about question 3. The question 3 is network topology diagram. First, routers. We have two routers, R1 and R2. R1, the router serves as the central connection point for the R1 bridge, and R2. The router connects the R2 bridge and is linked to the R1 router via one link. And switches, we have to switch S1 and S2. S1 connect to the router in R1 and provides connect network access to two PC, is that PC0 and PC1, and S2 connect to the router in R2 and provides network access to two PC. The PC is PC2 and PC3. And we have the two PCs, four PCs. The PC is in network S1, PC0 and PC1, in the network S2, PC2 and PC3 for one link. The one connect red line link the router 1 and router 2. The IP range for the one segment is 221.10.0.0/24, and we have two subnets. The first subnet is 125.128.0.0/8 for the R1 LAN connecting PC0 and PC1, and 130.0.0.0/16 for the R2 line connecting PC2 and PC3. And we have the external network documentation. First, device documentation. Router configuration, record router module ISR 4321, IP address for LAN and WAN interface, and router protocol, and any firewall rules for NAT configuration. Switch configuration include model number 296024TT, IP addressing if management, VLAN configuration and port accessment, and end devices. Document the IP address, MAC address, and any special configuration for each PC in the network. And network baseline, traffic baseline. Record normal traffic level, bandwidth utilized, and latency metrics for the WAN link and each LAN. This help identify anomalies and device perform baseline, monitor CPU, memory usage, and throughput of router and switch to detect abnormal performance threats. And network diagram, maintain and update network topology diagram that reflect any changes in configuration or physical layout. It's by keeping these um, details and update document, network administrator can quickly troubleshoot and manage to change the LAN and WAN environments. Here's the addressing table that R1 as interface G0/0/0, and then other serial interface, and R2 also has a gigabyte and serial, and we have the 4 PCs and IP addresses for R1 for gigabyte 126.128.0.1 for serial interface 221.10.0.1, and the two subnets is 255.0.0.0 and 255.255.255.0. The default gateway is an A, and R2 also we have a gigabyte and serial interface. The IP address is 130.0.0.01. Subnet is 255.255.0.0, and serial interfaces 221.10.0.2, 255.255.255.255.0, and for the PC0, the IP address is 126.128.0.2, and the subnet 255.0.0.0. The default gateway is 126.128.0.1. The PC1 126.128.0.3 and 255.0.0.0, and default gateway is 126.128.0.1. And for PC2, the IP address 130.0.0.2, and the subnet is 255.255 and .0.0. The default gateway is 130.0.0.1, and the IP address for PC3 130.0.0.03. The subnet is same and default gateway also same. Okay, let's we start to do the packetizer. We firstly enable the serial ports in the routers. Okay, this is already enabled, and for we rename it for R1, and okay, for router 2 we only have the gigabyte. We add the serial ports on. Okay, we connecting the cable to straight through cable PC to switch, and also add the PC2 to switch. Okay, we rename the switch also 1 and and another switch 2, and switch 2. Okay, now we have the serial ports in gigabytes. We connect to the gigabytes to router R1, and then switch 2 to R2. When we connect the serial cables, okay, okay, we enter the IP for gigabytes first. For gigabyte 0, we enter the IP 251.128.0.1. Enter and on. After that, we set the IP for PC0 to 6.128.0.2. Enter. The default gateway 126.128.0.1, and we enter the IP for PC1 126.128.0.3 and 126.128.0.1. Okay, we're going to enter our gigabyte for R2. Going to gigabyte. First of all, we have to rename first. Rename as R2. Enter and go to gigabyte 130.0.0.1 on. Just that for serial interface we on also. After that we have to enter the serial interface for R1 also. For R2 serial interface 221.10.0.2. Enter on. We set the IP for PC2 130.0.0.2. Enter. We set the default gateway as router's gigabyte interface 1. And for PC3 130.0.0.0.3. Enter. And we set the default gateway 0.0.0.1. And we have to enter the serial port for R1 221.10.0.1. Enter on. Okay. We try to ping PC0 to router 1. Okay, successful. After that, we try to ping PC2 to router 2. Successful. Okay. We try to do PC1 and router 1. Successful. And PC3 and router 1. Successful. We try to ping PC0 to PC1. Successful. And PC2 to PC3. Okay. And then we try to ping PC0 to router 2. Fail. And PC1 to router 2. Fail. And then PC2 to router 1 also fail. We have to enter the RIP For the network, we have the 3 network IDs. We have to enter in the 2 routers. The IP address 126.0.258.0.0, add that to 2 to 1 dot 10 dot 0 dot 0. We add it, and then 130.0.0.0. We add the same as router 1 we do in router 2. We enter all our network IDs 128.0.0, add, and 2 to 1 dot 10 dot 0 dot 0, add, and then another one more 0 and add. Okay, we try to ping PC0 to router 2, successful. And then we also can do like in a command prompt, we get the serial for IP addresses, copy, and we ping from PC1. Yeah, successful. And we're going to get, okay, we ping PC2, command prompt, ping for R1, successful. And we try to ping PC0, 0.2. Yeah, successful. Okay, we can ping to all the devices. In conclusion, establishing a WAN is crucially for connecting the company branch and enabling a unifying communication, centralized resource access, and seamless collaboration across regions. By carefully selecting connectivity options, whether traditional, modern, or internet-based, like MPLS, Internet WAN, VPN, the network can balance performance, scalability, and cost effectivity. A structured troubleshooting process supported by internal software and hardware tools ensure quick resolution of connectivity issues such as latency, disconnecting, and bandwidth limitation. And the documentation includes device configuration and network baseline. It vital for effective maintenance for future growth, creating a reliable WAN foundation that support the company expand needs. That's all from our group. Thank you.